Okay. Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillah ar-Rahman ar-Rahim. So we are continuing with the last few slides, I think, from the last part of session 6, which is about joining and map. So we are already, I think, here. Okay, so we discussed, the last thing we discussed last time was the join command, which joins two tables. Okay, we join two tables over a common column, and we add columns, the other columns from both tables. Now, given the example that we discussed last time, when we had the drinks and the discounts, we want to generate that table. In that table, we have each drink and the cafe that offers that drink, and we also want to compute the discounted price. Remember that we have two tables. We have the drinks and their original price, and we have another table that has for each, or for some cafes, the discount that they offer. So we want to generate this. For each drink here, we want to have the discounted price for it. Or at least the drinks that have discounts, we want the discounted price. That's actually more accurate. How can we do that?
We need to join drinks table with discounts.
Okay, so this is the step that we did last time, right? So we will join these two tables, and doing that, let me get back to the previous slide, we will get this table. Okay, so let's now assume that we have this table, and we want to get now, what is remaining now after getting this table? The discounted price. How can we get it?
We add a function
Yes.
that will calculate the discounted price.
Okay. How can we do that? So now we have this table. Okay. Let's say that we want to add another column that will have the discounted price. How can we compute and add, of course, this column? Yes.
Making the function and apply it to the two columns, price and column.
Yes, very good. So one way is to have a function, okay, and that function will compute the discounted price, and we apply it on price and coupon. Okay, so this function will have two arguments, two parameters. It will take the price, the original price, and the discount, and return back the discounted price. Okay. Now, when we do, if you remember the apply function, it will take this function and take the two columns, and that means that it will be applied on every row, okay, and produce an array. Now we can take this array and add it as a column to the table. Okay. Any other way we can do it without the apply function? So you understand how we do it with the apply function? Okay. Any other ideas? Yes.
Yes, we can take the coupon column.
Yes.
Say 1 minus the percentage in the coupon column, and then multiply by.
Yes. So we do it by the operations directly on the columns. Okay. Of course, we cannot do it directly on the columns of the tables. We have to extract them as arrays. Okay, and then if you remember earlier, we said that we can do operations over arrays. Okay, so if we have this array and that array, now we can do the operation that we can implement as a function, but we don't have to. We can do that operation on these two arrays. Doing that, will give us another array, right, which will be the discounted prices. Now we can add it back to the table. Is that clear? Is that clear? Yes. Okay, so let's see this. We need to. So just to upload the tables, and this is the join operation that we did last time. Then this is the second solution that we mentioned. We can take the price column and the coupon column, and we do the operation. So this command, of course, can be on multiple lines. So the first step is to take this column and do the operation on the other, take the two columns and do the operation on them. Okay, so this line is doing the operation of getting the discounted price on the two columns after getting them as arrays, of course. Now we have the array we added with column command to the table. Okay, so this is directly doing the operation on the two arrays. We can also define the discounting function as a function, discounting operation as a function, and apply it on the two columns. Okay, applying it to the two columns give us an array we add it as a column. Okay, any question about these two ways? Here? Okay. So we are done with this. Now the challenging question, okay, that I want you also to try as a bonus question in the homework. You can attach it to the end of the second part. Just give it a new title and then you add your solution. So the question here is about generating this table, which is giving us the cheapest discounted drink for each cafe. So in the previous question, we wanted the discount price for everything. Here, we just want to keep the drink for each cafe, the drink that will give us the cheapest discounted price.
For each cafe?
For each cafe. Of course, among the cafes that are offering discounts, right? If the cafe doesn't offer a discount. Okay? So the question is clear? Okay. This is a summary of the methods that we discussed so far. So we discussed how we select columns, how we select rows. So this is columns, of course. This is rows. How to sort, how to select some rows also. How to apply a function on multiple columns. How to group. And we also discussed pivot tables, right? And finally join. So this is just a summary of all the commands. And this is a link to the documentation of the tables where you will find the list of all the methods. The last thing that we want to cover in this part of the sixth session is maps. And maps is a very nice visualization tool in which we can show on a map the position of places, the location of places on the map. So let's see a demo on that. Quick demo. So this is a data set where it lists some of the train stations in the US. For each station, so each row here is a train station. It has the name and it has also the latitude and longitude. Okay, what is the latitude and longitude? These are the coordinates of the location on the map. Okay, in Arabic, خطوط الطول والعرض. So given that these two numbers, we can know exactly where is that train on the map. So given that data set, we can show this location, the location of these train stations on the map using the marker object and the map table function. So the marker and circle are both used to visualize maps, visualize locations on maps. And they work on other structures than table, but our focus will be on table. How can we visualize the locations given in a table on the map? So map table will work on a table where the first column indicates the latitude, and the second indicates the longitude, and the third indicates the name of the location. Given only these three columns, we can put them and visualize them on a map, as we will see here. And you can zoom in, you can zoom out. Okay, it's just an interactive map. And each of these markers came from one row in the table, exactly on the location where it is indicated by the longitude and latitude. When you click on a marker, on one of the markers, it should give you the name, but for some reason it doesn't work on my machine. I don't know why, but the name should be here. Actually, if you look at the textbook, you will see that in the example in section 8.5, you will see that it works that way, or it should work that way. So if you click on any of the markers, you will get the name of the location. Where did we get the name? From the column, right? From the third column, we give the names of these locations. So the name should be also here, but for some reason it doesn't show on my machine. Another function that we can use also to show locations on the map is circle.mapTable. So circle, the only difference between circle and marker is that instead of showing these markers, we will get circle, okay, with specific size and also color. So in this case, in this command, you will see in these two lines, you will see that our focus here will be on San Francisco, just a subset of the locations, and then we give the table that has the latitude, longitude, and name, and also there are two optional arguments here to indicate what is the color that we want to show the circles with and the radius of each circle. So if we do that, we'll get a map of the locations on San Francisco. Each one is indicated by a circle of that color, of the green color, and that radius. Okay, so these are nice visualization tools to show you where, if you have location data, then you can see them on the map. Also, as we will see in the syntax very soon, it's not only the first three columns that are considered. If you put a fourth column, it will be the color of the marker or the circle. So you can actually change the color based on the locations. You can color some locations green, some locations blue, and so on as you wish. And also the size, I think, can be different for each row from the fifth column. So if we look at the slide here, this is the syntax. So you put here marker or circle, dot map table, and then you give the table. The table, by definition, column 0 should be latitude, column 1 should be the longitudes, and then labels, then colors, then sizes. So that gives you flexibility on how to color each location. So you might select some locations to color them in a specific color for a specific reason. They have some meaning, and the others with different colors and so on. And even the size of the circle can be indicated here. You can also apply You can apply the same color and same size to all of them with arguments as we saw in the previous example. Okay, so you either indicate that for every location from the table itself, or you can say I want all of them to be colored blue and the circles will be of that radius. Okay. If you put them in the table. If the table has a column that indicates the color, then each one will be colored differently with the color that you indicate in the table. Okay. So if we want to do that, for example, then in that table, you can add to the table here at some point a column that is called color, and you put the color, okay, in that position of the table. It assumes a specific order. If you do that, then each row has its own color and it will be colored differently. Okay. Any questions about maps? Okay, with that we are done with session 6, and now we will start a new session. This new session is about randomness and specifically random sampling. When we talk about random sampling, it needs, of course, some knowledge of probabilities. When we talk about probabilities, we need to talk about counting, right? when we talk about counting, we need to talk about loops and conditional statements. So what we will start with in this session is to talk about comparisons and talk about conditional statements and loops in Python, and then we will apply that on what we need for randomness. So we'll start with comparison and booleans. So in Python, we can of course compare two values using the traditional logical operators like greater than or equal, and so on. Each of these expressions will give us a Boolean value. So that's as usual in programming. Maybe the last one is a bit unusual, but in Python this is valid, and that was indicated earlier even in the textbook, that we can have something like this. Okay, so that means that 2 is less than x and x is less than 5. So this expression will be true only if both conditions are true. And of course, this one is different from that, right? This one is assignment statement. This one is a logical expression. Okay, before that, yeah. So now that we did a comparison, we can also aggregate comparisons. Okay, what does that mean? It means that if I have an array of Boolean values, array of true and false, we can sum them. Okay, and summing, I think we saw something like that before. When we sum this array, the true has actually a value of 1 and false has a value of 0. So if we sum, then we'll get the number of true values in the array. So of course, if we sum of an array of numbers of zeros and ones, we will get the number. If we have 2, false 2, we'll get the same number. If we have that array, we'll get the same. And if we have that array of Boolean values, we will get the sum of them. And you will see later how useful this is in doing sampling and getting the distribution of samples. Let's do a quick demo here. One thing that I forgot to mention, there is a section in the textbook which is 8.5 that's related to the previous session. This section is giving us a very nice application that combines all of the methods that we discussed related to tables. Okay, it's a very nice application. Please go through it. Okay, we'll not discuss it in detail in class, but it is there. Please go through it. It will show you an example of combining all of these different methods for one application. Getting back to the demo here. So what do you expect as a result of this expression? True. About this one? Boolean. Bool. Okay. How about this one? True, right? This is true. Okay. How about this one? Error. Why is that? Yeah, because that's not the true value in Python. True value in Python starts with T. How about this one? Okay, error or nothing or true, or I heard multiple answers. What do you think? Huh? Error or not? Nothing. So we'll get nothing, but that's not an error. So I can say 3 equals 3. Okay, so we just mentioned that when we use 1 equal sign, that means assignment statement. So of course this is invalid. Okay, because we cannot assign something to a number. It has to be a variable. How about this one then? Okay, so that's not error, that's the right thing. So this should be 2. How about this one? 2, of course. Okay, how about this one? Nothing. This is just an assignment statement. So x will be 14 and y will be 3. How about this one? False. This one? Oh, this one? 2 and false. I heard someone said 2 and false. Okay, 2. How about this one? True or invalid? True. Because x is what? Is x 14, right? How about this one? So x is 14, y is 3. So x minus y is 11. Okay, so it's false, of course, because one of them is false. Okay, how about this one? 2. Okay, now we can do also comparisons with arrays, so this is more fun. So if we define an array pits, so pits is just an array that has these values. If I say pits equal cat, what will be the result? False. Okay. Error. Other guesses? Array. Okay, array which will contain true and false. Based on?
Because it will compare.
Yes, so it will compare each element with cat. Okay, so yes, so remember that we can do this over arrays also. So when we compare an array with a value, that means that each element in the array will be compared with that value, so the result will be an array of truths and falses. Okay, is that clear? Okay, now how about this one?
3.
That's easy, right? That's 3. Okay, we are doing that because we will compare it with this sum. What do you think about this sum? 3, because we have 3, 2 here. Okay, so here we can also add, we can sum over Boolean values. So that's what we saw in the slide. You can add Boolean values. How about this one? 2. Why is it 2? Because we have 2 dogs, right, in the array. Okay. Now the same thing we can do with count with numpy.count non-zero. I think we saw that earlier in the course. So we will get the same result. So either this or that, maybe some is easier, or easier to remember at least. Now if we get a range from 20 to 30, now when we say x is greater than 28, what will we get? What will be the values of the array? I understand. What value exactly? The last 2 values will be true, the others will be false. Okay, any question about that? Okay, now we'll talk about control statements, and mainly we'll talk about if and for. We'll start with the if statement. What is the purpose of the if statement? We check a condition, and based on the value of that condition, we either do some code, some commands, or the others. So let's see a demo on that. Here we will play a game. Let's say that the game is by rolling a die. If we roll a die and we get 1 or 2, if I get 1 or 2, then I will give you a chocolate bar. If we get 3 or 4, we do nothing. If we get 5 or 6, I give you a chocolate bar. Okay? When you give me a chocolate bar, that means that I will get a value of 1. If we do nothing, value of 0. If I give you chocolate bar, the result for me will be -1. Okay? Now, if I want to write that in a function, here is one trial. So here is how if statement is written first. So we say if, and then a condition, and notice that we don't have to put the parentheses. There is no parentheses here, just the condition, and then colon. Okay? Then we put the body of the if statement that will be executed if that condition is true. Okay? So if that condition is true, then we will do this. Now what happens if I call this function? So do you understand this function now? Okay. If I call this function this way, one round of 1, what will I get? 1. Why is that? Because roll will be 1. 1 is less than or equal to 2, then it will return 1. So let's see that. Okay. Now if I call it with 4, what will happen? Nothing. Or maybe error. Okay.
I think nothing because we didn't specify what happened.
Yes, so in Python, you can do something like that. In Java, I think you can't. Okay? But in Python, you can return or you don't. If you don't return, then it will not, you will not get any value. So if you call one round of 4, you will get nothing. Okay? Nothing happened, not even an error. Okay? Type. Is that what we want to do? No. Okay? So what do we want to do? How can we change this? Yes, so we want to check the value of the role. If it's 1 or 2, then we return 1. Else if it's less than or equal to 4, right? We should return 0. We said 0 based on the game here. We said 0. Okay, we do nothing, but that means that 0. We should return 0. If it's then else if it's less than or equal to 6, then we should return -1. So that's the function that we should do. Okay, let's look at this function and see if that's what we want. So what's the meaning of this? If roll is less than or equal to 2, we will return 1. Okay? Else if needs another condition. Okay, so else if roll is less than or equal to 4, then we'll return 0. Else if roll is less than or equal to 6, we'll return -1. So with if, else if, all of these conditions will be checked one by one. Once 1 is true, then its part will be executed and this statement is done. Okay, type. What if all of them are false? In that function, we'll do nothing, but you can also add else if we want. Okay, so else, if we have else, then if all the conditions are false, then the else part will be executed. And of course, else doesn't have a condition, because that's anything else other than the other conditions. Okay. Type. Let's try calling this function. 1 round of 4, what should you expect? 0. Okay, so we get nothing because we didn't actually have this defined yet. So this is 0. Okay, 1 round of 6? -1. Okay, 1 round of 15? Nothing. Okay, nothing. Why is that? Because we didn't specify if roll is greater than 6, what will happen. Type. If I want to change this function, assuming that the input is always less than or equal to 6, what should I change? Or should I change anything in that function? Okay. Now we have this function. Okay. This function doesn't assume that roll is always between 1 and 6. Okay? Because actually it handles the case when roll is greater than 6, right? By just returning nothing. But by not returning anything. Type. If we assume that roll is always less than or equal to 6, what should I change here? Why do you need a for loop here? Huh? Else. Where should I put else statement? After the last one?
But I will put with or condition because it will be less than 1 and it will be greater than 6. So I will put else if.
So let's focus on the other's end, which is 6. Okay, forget about the beginning.
Else if roll greater than 6, return something.
Okay, but that's what I want to avoid. I want the function to assume already that it will never get a number that is beyond 6. What can we change here? Do we need to check this condition then? No, we don't need to check this condition, right? So what should we do instead of this? Just else. Okay, so instead of this line, we just replace it with else, and that's it. Because else means that it will be 5 or 6. Okay? assuming that it will never be beyond 6. Okay. Good. Any question about this? Now let's talk about random selection. So what do you mean by random selection? We have a list of items or values, and we randomly want to select one of them or more. Okay, that's what we mean by random selection. Sometimes it's called also random sampling. Okay, we have a list of items or values, and we want to sample or select one or more items from them. So in Python, we can do that using NumPy function, which is random.choice. So random.choice selects uniformly at random. What do you mean by uniformly?
It's like a step, not order.
Not a step.
No condition, no order.
No. Have you heard about uniform distribution before? Oh no, that's not uniform at all. Yeah. Okay. Huh?
We choose at
Equal probability.
yes.
Right? So uniform selection here means that if I have 10 items I want to select from them uniformly, that means that each one of them can be selected with the same probability. All of them are equally probable to be selected. Okay? That's what we mean by uniform distribution or uniform sampling. Okay? We assume that all of them can be selected with the same probability. There is no preference among them in sampling or selection. So this function does the uniform sampling from an array of values, of course, and with a specified number of times. So it will do this sampling. By default, it will do it once, but we can also specify a number of times. That means that I can say sample 3 times from that array. Okay, so it will give me 3 samples. Now, this is by itself is not enough to know about the function. If I said I can give a specified number of times, I have to say also whether this will be with replacement or without replacement. What do you mean by with replacement or without replacement? If I have a bag, that's the traditional example in statistics, probability and statistics, right? If I have a bag that has colored balls, okay, let's say we have 10 balls, and I asked you to sample one of them at random without looking at them. Okay, so you will sample one. Right. If I asked you to sample another one, there are 2 options. You can return the first ball back and sample again, or you sample from what remained in the bag already. The first way is called with replacement. Okay? Because every sample in this case will be similar. Not similar, I mean similar in the way that you sample, or similar in the list that we sampled from. Without replacement means that the first one we sampled, we will not put back. So we will only sample from the remaining ones. If I sample the second one, then what will remain is 8 balls now for the third one, and so on. Okay, that's what we mean by with replacement. Okay, so without replacement, we still sample from the same list. Okay, every time. Without replacement means that we sample from the remaining. With replacement, we sample from the same list of values. So this function works with replacement. So here is the syntax of the function. Choice takes 2 arguments. One of them is required and the other is optional. The required, of course, is the array from which we will sample from, and the optional one is the sample size. That's how many samples we want to get. We call it the sample size. If we didn't give the sample size, then the default value is 1. Okay, we'll sample just once. So let's see a demo on that. Okay, we'll start from here. So the experiment groups is an array of 2 values, treatment and control. When did we hear about these 2 words? Causality. Okay, so when we talked about experiments, right? If I want to establish causality, then I have to have two groups, treatment and control. And if you remember when we talked about randomized controlled experiment, we said that we want to distribute the individuals randomly, okay, over the two groups, right? The group that will have the treatment and the other group, which we'll call it the control group. So so here this is the array. Now, if I call choice on that array, what will happen? What will we get? So the choice is the function that we just saw on the slide. Yes. Do we know which one? No. So that's randomly we will get one of them. Okay. So this is how we can do this sampling for the experiments. Right? If I want to take this individual randomly, I will assign that individual to either treatment or control. So I can do it that way. What if I call the function again? What will I get? We don't know, right? We don't know. We don't know exactly what we will get. So this case we got control. If we call it a third time, we get treatment, and so on. Okay, so we can even call it multiple times. You get, I don't know why it's stuck now, treatment, but we eventually get control. So we can, of course, randomly get. So we cannot anticipate the outcome of one sample, right? When can we say that we have some confidence on the distribution?
When there is a pattern.
What do you mean by pattern?
What's the question?
Okay, so we said that we don't know when we call choice, we don't know what we will get, right? When can we say that we are quite confident that we will get 50% control and 50%? Yes. So if we increase the sample size, and we counted how many times we got control and experiment, probably we'll have some confidence that we will get a uniform distribution. We'll get maybe 50% and 50%, and we'll do something like that very soon. What if we called choice with the same array but with 10? What will we get? 10 samples. 10 samples. Okay, we'll get 10 samples over treatment and control. Now tell me, what will we get if we call this now?
Array of Boolean, true or false?
Yes, array of Boolean, but remember here we have some.
How many?
Okay, what will be the count?
Of the true part
Of control, right?
Yes.
How many?
We don't know.
We don't know. Why we don't know? But we have this, right?
No, it's not.
Yeah, that's a different one. Okay, so that's a different sample. Okay, so we don't know how many we get control. Type. If we do it over treatment, what number we will get? Less than or equal to 10, and we don't know also, right? Because that's a third sample, so we don't know. We get even 7. If we run it again, we get another number. Now, if we want to keep the same sample and we just count how many of them are control and treatment, we need to save them. Okay. Now, if we sum over treatment, what will we get? 3, and control 7, of course, because all of them are 10. Here's another experiment with the die. So if I have the die faces, of course, from 1 to 6, so I can randomly select one of them. So when I call choice over die faces now, I will get a number between 1 and 6, right? So here is 2. I can put that in a function just to be easily called later as an experiment. So if I want to do that multiple times, then I simulate one experiment, and one experiment here is rolling a die. And then remember the one round function, the game that we earlier implemented. Do you remember that? Okay, so if we call that by one round, this is for, in that example, like the experiment that we want to do. This is one experiment, so that's simulating an experiment. So yes, that's the game itself. You roll a die, and then based on that, you get a reward, whether you give the chocolate bar or you get the chocolate bar or something like that. And of course, we simulate that by the numbers 1, -1, and 0. Okay, now if we call simulate one roll, what will we get? We don't know. We get a number between 1 and 6? No. A -1 to 1. Okay, remember, we have the die first. That will give us a number between 1 and 6, and then call it with one round will give us the actual experiment, which will give us -1, 0, and 1. So in this case, we'll get 0. Okay, next time we will see how we can add this up in one array to save the simulation, the experiments that we do, so that we can analyze doing that simulation for multiple times. Okay, any questions? Okay, thank you.